Alright, this video will show that the constant angular speed of the sun across the sky is impossible on a flat Earth. We can observe every day that the sun will rotate about 15 degrees per hour every day, moving across the sky 180 degrees in 12 hours. Especially if you have the camera or whatever polarly aligned to rotate in line with the axis of the Earth. This is how an equatorial mount works. If you have questions, I have a video on it. Go and look at my thing, look up the Wolfies contest. Alright, so what we have here is like a 24-hour clock face. 15 degrees wrapped around. So imagine this is the North Pole and this is the sun location. Guys believe that, to my understanding, flat earthers believe that the sun rotates around the North Pole at a constant distance and speed. If I'm wrong, correct me, but this is my understanding, that it is moving around in a circle around this North Pole, which is right there. Now the problem is that you're never observing the sun at the North Pole. You're observing off the North Pole. So if you're here, your cardinal direction is going to be north, this is going to be east, this is going to be west. This will represent the sun at midnight, 1, 2, 3, 4, noon, all the way back to midnight. So if you look at here, your viewing angle to the sun will change. Notice here that if I'm at this latitude, I am going to see the sun rotate across my sky 180 degrees in 8 hours. That never happens. If you look even closer, you can see that there's a drastic angular change. But you may say, oh, you won't notice it from here to here because that's when you see the sun. But if you're at the North Pole, or if you're in Alaska with the 24-hour sun, there should be a drastic change in speed through the day. You can see here is almost twice as fast as it is on the midnight sun. But you're probably going to say, oh, you're not in the right latitude. If you calculate the distance by latitude to the North Pole to Fairbanks, Alaska, and from Fairbanks, Alaska to the Tropic of Cancer, it's about a 60% or 40% distance. So that's where I aligned this at. This is where D. Marble observed the sun, and you can see that it moved 180 degrees in about 11 hours. Now the 180 degrees in 13 hours. But as you can see, it never changes speed. The angles from this side to this side is drastically different. Angles here to here are noticeably different. If you measure them out, you will be able to find there's a big difference, measurable. I have an equatorial mount that I made myself, using 2 ball joints and lining it to the poles, using my latitude and lining it up with true north. I can use this with 2 ball mounts off a tripod and my phone as a compass. And I recorded at a constant 15-degree angle change per hour. The reason why this can be different is because, one, imagine you're watching a race car going around the track at a constant speed, but you're closer to one side. If you look on the other side, the time it takes, the angle that it's crossing your view will be slower than the angles going across your view when it's closer. So if you're right next to the track, you're going to see that car zip by really quickly, versus the other side, it's going to be going look like it's moving a little bit slower, even though the car itself is moving across the same speed. This is why the sun angle, constant angle change, is impossible on a flat Earth. This is what's called parallax. So, thanks to D. Marble and Chris, UK, this is exactly what you're talking about in your model about the globe. Unfortunately, in my other video, I showed that it's perfectly feasible on the globe, but it's impossible on a flat Earth. Thank you.